EMF in each side PD across each side. First, what is the B bar? B bar. So what is the area of the loop? 3 into 2. Magnetic field is varying. So what is the EMF induced equal to S into dB by dt. The magnetic field varies with the time 4 Tesla per second. So area of this will be 2 into 3 and this is 4. 2 3 is 6. So 24 volt is what? Net EMF induced in the loop. How much in each side? So don't divide by 4 because the EMF induced is proportional to length. Go back to the basic formula. The EMF induced in the loop is proportional to the length. So therefore, EMF induced in 1, 2 and 2, 3. 2 times of EMF induced in 1, 2, 2 times of EMF induced in 2, 3. There should be equal to EMF induced in the loop. On what basis? What all EMF induced will be shared by each side. Will be shared by each side, and EMF is proportional to length. So therefore, E12 by E23 should be equal to 3 by 2. We know total EMF is 24 volt. So solving this 192, we'll get the EMF induced in each side. Substituting this, so 2E12. E12 will substitute here. So this will be 3 by 2, E23, 2E23 should be equal to 24. So 5 E23 is equal to 24, or E23 equal to 24 by 5. 4.8 volt. Then how much E12 will be? 3 by 2 by 4.8. Anybody value?
7.2.
7.2. So there's a EMF induced in each side. Then what we should do? We should replace a cell, equivalent cell. How to give polarity of cell? From Lenz's law, B bar into the plane. Negative flux, the B bar is into the plane and increasing. Negative flux defined by negative, EMF induced positive. So therefore the induced current in the circuit will flow anti-clockwise. So keeping that induced current, you should assume the polarity. So there should be a cell which will push that current, the assumption. So therefore the polarity should be given, keeping that induced current in their mind. So then what is the resistance of this? Lambda into 3, 6 ohm. EMF induced here is how much? 7 point. E12 7.2 volt. No, this is 7.2 volt. This will be 4 ohm. Then 4.8 volt. So this will be the direction of current. Now you write potential differences. This EMF, select a potential difference across 1, 2 is not 4.8 volt. Then who is responsible for this flow of current? Not potential difference. I think previous class I just made a conclusion. You check it now, this current will flow from higher to lower potential, lower to higher potential. So therefore the potential is not defined. Not defined means you cannot calculate. No, you connect voltmeter across 1 to it will read. So not defined, I think you should not think that will not exist. Potential will not exist. Potential is not defined. I think a lot of difference is there. You connect voltmeter, the voltmeter will read potential difference. And it's meaningless. Therefore, we say not defined. Not exist, not defined. I think the words will give a lot of differences there in that one here. Even you calculate potential difference, it's of no use because the current is not due to potential difference. Apply the same the conventions like KVL, then calculate the potential differences. So therefore, the EMF, not like if you get any the loop, the EMF induced in each side should be proportional to its length. Are you able to correlate? That's why I just picked up. Earlier it was square, no? 1/4, no. Here's a rectangular frame. If a triangular frame, right angle triangle comes. So different shaped loops, the EMF induced the side should be proportional to length. Keeping that in mind, you should carry on. What is the again expression for total current? Again, don't get deviated. The same Faraday's law by total resistance of the circuit. How much lambda into 3 plus 2 plus 3 plus 2. Don't get deviated again. You apply Faraday's law, you get the EMF induced in the loop and total resistance of the circuit. So like that, we'll get the current I. So this I, the current I flows due to induced electric field. There's a background. This is what needed for us. Next, we'll go for all logical type of questions. So there's a one firm conclusion what we are making.